Good afternoon, ladies and gentlemen. Thank you so much for joining us. We're proud to present our next speaker, Beau Christensen with Splunk. Please give him a warm welcome.
Good afternoon, everybody. I hope lunch was good. This talk is going to be on practical strategies for building distributed systems. Please complete the survey. We don't get a lot of feedback as speakers, so this is great for us. This is also a requirement for me, forward-looking statements. All this stuff may not be in production, et cetera, et cetera. This is me and why you should care about what I have to say. I work for a bunch of companies, mostly in Denver, in the Colorado area. Ping Identity for a long time, little company called Red Canary, VictorOps, and we were just acquired by Splunk about 6 months ago. So this is the hardest problem that you can do when building systems, so you should really think about why you're taking this on. For us, reliability is our most important feature as an incident management company that delivers you alerts when your stuff is down. The way I like to think about this, if you study Buddhism at all, there's a couple of different types. Theravada believes that at any one point in time, you can be perfect. Your systems right now may be perfect and running perfectly normally. Mahayana believes that the pursuit of perfection, that 1.0 that we're all after, is kind of the journey. There are lots of things that are acting against us every day. Business scale, bad actors, hackers, actual weather events, and users themselves. We're always somewhere in the middle between these two. This is the first distributed system that I built. It worked for probably 6 months and then fell apart horribly at scale. Yeah, I've definitely failed myself many times when building these things. So the first tip that I'm going to give you is make sure that you actually want to do this. A lot of times you'll run into large customers, dudes with ties on, that believe that your computers need to be everywhere in order to be reliable, and that's generally not the case. The complexity that we add when building distributed systems generally can make them a lot more fragile. Have you guys all seen this slide, like this week or last year at reInvent, where the company that builds these systems created like this giant graphic where they talk about failing over in minutes between multiple locations? Does anybody have more than 20,000 nodes in production? Anybody here? 10,000 nodes? Yeah? Yeah, okay. So there's a couple of us that are at like pretty good scale. But a lot of us don't have the time or the brain power to actually build stuff like this. We don't have these massive Death Star architectures. Most of our stuff still looks like this, where it's, this horrible diagram that somebody built in Visio with templates of, databases and middle-tier servers and whatnot. DNS failover and geographic redundancy generally looks like this in our brains. It's this nice, clean thing that we think about. When in reality, like our shit is all, different application versions. We have like a lot more servers in one location than the other. Our SQL servers are on fire. They're all in a data center and it's in like a floodplain somewhere. This is us, for the most part, as a community. So be honest about why you're doing this. If you're building core internet infrastructure, life, safety critical systems, your target market is mostly enterprise focused. If you're building blogging software, dating apps, or if you're Reddit still, like don't apparently go multiple regions. So tip number 2, identify seams in your application. So a seam is moving an application around without changing it. So there are lots of, you potentially have lots of apps inside of your infrastructure that you can move. You can push them into the cloud. You can create these shields around your application. Stateless apps, applications at the edge, if they have their own data tenancy themselves, these are all great attributes of a seam. diagram your app, study it. For us, like identifying endpoints and policies for escalations that have their own data tendency for us was a great exercise to go through. We identified this one at the edge. It was stateless. It had basically no data tendency for it, and it was easy to move. So you can build these things. You can build a shield around your application. You can redeploy this into the cloud, into Kubernetes, into containerized apps, anywhere. For us, the alert endpoint was the biggest win. Moving this into the cloud and putting a lot of redundancy into this particular application itself. This is the edge of our app. This can never hand you anything but a 200. I got you. We've got your alerts. We're going to store them and send them. So building a ton of redundancy into this, using caching and SQS servers and Route 53 at the edge was huge. It was a big win for us, and you can deploy these in front of your main application so that it can be moved back and forth between locations. We have a cool benchmark app that we run too against our endpoints. So deploying these into multiple regions and then running tests against them to qualify it outside of the production load is a huge tactic for us to really get comfortable with this new endpoint. And then you can kind of, Route 53 has great features where you can meter traffic back and forth, only do 10% of a load or less than if you want, and eventually carrying that into full production. Tip number 4, don't forget to do science. Resist the urge to go active right away once your shield has been deployed and once you have your applications in the data centers in the 2 different regions. Stay active passive for a while and make sure that you're studying the new system and how it's set. An example of an active passive system right here. At this point in time is a great time to really get to know it. Getting to know your application, studying the 4 golden signals if we've all read the Google SRE book. The network between the 2 locations is super important. Making sure your tunnel's reliable, understanding its traffic flow and state, building dashboards and alerts around this. Use this time in active passive mode as a safe moment in time to really study the application and your teams as well. Failure is definitely our greatest teacher. If I go back to the 3rd slide that I showed, that system that failed miserably taught me a lot about how to build these systems in the future and now when we have greater capability in our tools. It's also a Yoda quote now, if anybody's seen the latest movie, yeah. Chaos engineering really kind of brings this out and allows us to squeeze these big, terrible issues out of the system before going to production. If there's any leaders in the group too, you want to see major failures in an active system before you go full production, before you go full active. If everything looks fine, if everything's great and peachy and green all the time, something's wrong. You should exercise that system first. Your team needs to know how it fails before you go to production. And don't scold your team for having these big failures while you're still in this active passive mode. You want to see that. That should be a gateway to full active production. These tool sets, I'm sure you guys have heard tons of them. Gremlin's the new guys. I think they're like right over there. We've been using them in beta mode so far. They've been great. Yeah, crush your databases across multiple regions. That is a huge one. Scale of your load balancers, how quickly they scale. We all know ELBs have a hard time growing quickly. Scale downs for us were kind of the hardest part. Removing systems from the load that potentially have state. Test your alerts, test your monitoring using chaos tools, and test your team using game days. Chaos engineering and game days, for me anyway, are different. Game days are much more about the team itself and exercising the team in failure modes and high stress situations. So tip number 5, this shouldn't be a surprise to anyone at this conference, but use the cloud. Hybrid clouds or deploying lots of open source software between a cloud and a hardware data center are generally myths for normal sized companies. There's just too much to know. You don't have enough people. You don't have enough brain power on your team generally. Or if you do, it's centered in one guy that may leave. Use the tools that Amazon gives you, that any other cloud providers could give you to keep things as simple as possible. These are going to be examples of terrible system architectures that you should not ever deploy in a multi-master strategy. I'm sorry if these are any of yours. I found them on Google just searching like terrible system architectures. Like I don't even know what's going on here. Like this one looks like a spreadsheet. It's like a accountant built this. I don't know what's going on. This one, same. Like I can't follow a flow of data at all anywhere here. This one looks like a monster. I actually built this one. It was part of the system that failed miserably. Don't build systems that look like spreadsheets, especially if you're doing some of the most complex stuff you can do across multiple regions, right? Make sure you're keeping it as simple as possible. Aurora Multi-Master was huge for us in managing state across regions. The GSLB services that Route 53 provides, like I said earlier, can meter traffic for you. Eventually consistent data, so some of the stuff that doesn't require to be in your lap right away. Streaming, and SQS is one of the most used tools for us in an architecture, just because how durable it is as a queuing platform. Choose services that suit the needs of your application. Again, load balancing, queuing, streaming are all right up there, and they will help you tackle the state monster. So everybody's application has to maintain state somewhere. Tightly controlling this state is the key to your active-active distribution. Keep it as small as you possibly can. If you have giant terabytes of data that maintains the state for your app that you're trying to ship back and forth between coastlines, is not going to work at all. These SQL servers are going to explode, or even Aurora at that scale. You want to keep it as small as possible. You have a much better chance of success when it looks like this. Again, RDS, Dynamo, all the database applications that Amazon provides us as services really help you out here. We used to have to build these ourselves with open source tools like Galera that would be really scary when they did fail. Now we have services that do this for us. Use them. So in summary, make sure you really, really need to do this. It's the hardest thing we can do in all of computing. Identify seams in your application to help you create a shield to move your main app between regions. Don't forget to do science before you go to production. Chaos engineering, test your team, test your services before. Use cloud services. They're your friend. You don't have to build everything yourself. Don't build the giant spreadsheet diagram. And tightly control your state monster. And you should be okay. Eventually, you'll get to this, where you have kind of distributed endpoints around your apps. You'll be in multiple core locations behind the scenes that are maintaining state between each other. You can lose any one of these at any point in time, and everything continues to operate. Everything continues to scale on its own. This is the end goal that we should all be after, and that's all I have. I'll be around for questions, probably, if anybody has any, but thanks.